Okay, so by now we know how to solve functions. Like that's our linear function. This is our quadratic function. If you set that equation to 0, f of x to 0, you will, let me just write it somewhere here. You set that equation to 0, you will end up with something like ax plus b is equal to 0. We pretty much know how to solve that. If you have f of x is equal to 0, you set that, you have f of x here, you set that equal to 0. You have an expression that looks like the following: ax squared plus bx plus c. And if that is 0, you pretty much also know how to solve that. We have an equation to solve that. You know, it's x is equal to minus b plus minus b squared minus 4ac. For some of you, I've actually derived these equations from first principles, like from scratch, you know, from nothing. I've actually derived it for you. So you kind of know exactly where it comes from. You know that if you don't want to use the equation, you can complete a square or you can do factors. You know, so probably one of the things that I could be assuming is that you sort of like understand that, but that's bad. So let's sort of like take some example to just make sure that we're on the same page with that. So if someone gives you something like what? Just someone gives you something like x squared minus x minus 6 is equal to 0. Can people quickly solve this for me? You know, you can use it using an equation, which is x minus b plus minus square root of b squared minus 4ac. Just give it a try. Over 2a, you know. Or you can choose not to use the equation and use factors. In the class preceding this, I was showing people how to factorize, so you can factorize and do all sorts of things. I won't use this, so I will use this right-hand side, and then you can compare your answers that you're getting. But of course, I'll talk a lot about these in that class at 5. Oh, my apologies. I don't know what happened there. Oh my goodness. I'll talk a lot about this in that class at 5. So yeah, people can hop in there. Okay, this is 3, this is 2, this is minus, this is plus. So my x plus 2 is equal to 0. X is equal to negative 2, or x is equal to 3. You guys can compare with anyone who's getting it. If you've solved it and it's the same, just raise your hand. Just raise your hand, or just say sharp if you, yes, thank you. Yes, thank you, Ase. We've solved it and it's the same. Otherwise, if it's not the same, just, you can speak to me. We can talk about it. You can just speak even. If you've solved it, raise your hand, guys, so that I can see. If everyone raises their hand, then I can move on. So no one is getting it correct. Is that the indication?
I got it right, sir.
Okay, cool. Noted.
I raised my hand to indicate that I got it right.
Okay, noted. Noted, guys, noted. Okay, people don't generally seem like they have a problem with this. Let's move on. Okay, so moving on, we're gonna start doing, if you think about that, I started with a linear function. I said, apparently no one had a problem at all. We've been solving linear equations. Come with a quadratic, people are getting a great sense of what's going on here. So we're moving on to our cubic functions. Someone gives you ax cubed plus bx squared plus cx plus d. I'll talk further about this maybe in tomorrow's class, but yes, today we're just going to be factorizing it. Maybe I might talk further because this class is long. I might. Okay, cool. So what do we do here? Right, this is, suppose that this is set equal to 0, f of x, then we have ax cubed plus bx squared plus cx plus d. And this is basically equal to 0. We have to solve this equation now. This is a cubic equation. We now have to solve it. Maybe for something that I might have not mentioned it before, if you have a linear function, the values of x that you have are 1. If you have a quadratic function, this is a bad color, 1. If you have a quadratic, your solutions must be 2. And if you have a cubic, your solutions must be 3. So you must have 3 values of x. I'm not talking about this function. I'm not talking about this equation as a function now. That would be probably tomorrow or tonight's topic a bit later in this class. Okay, anyway. So now we're gonna have to start learning how to factorize this. I have a couple of examples to do that. Yes. So let's look at the examples. And as I've told you guys, I have a preference to the method that I use to factorize these, or maybe to sort of like solve these. I have a preference. You guys would recognize, you see, these are the things that you can do. Can you guys recognize this problem? Anyone who was in a class before this class, can they recognize this? Anyone? Probably x minus 1 cubed.
Yes, sir.
Yes. So some of these problems, you can look at them and be like, I've seen you. And probably that's the power of constant practice or practicing all the time. But anyway, we'll approach it with the way that we approach it. So the first thing that you must do when you have this situation or this kind of problem, you must guess a solution. Guess a solution, right? Guess your first solution. Right, so when you can guess x is equal to 1, or you can change it to x is equal to -1, and then you can make it x equal to 2 or x is equal to -2. So those are your guesses. You are guessing there. And then once you've guessed your solution, or your solution is, you're gonna try to substitute it in your function and you look at what you get, right? Can someone tell me what they get for F1? And probably someone do F, the second one, F -1, and then someone.
F1 is 0, sir.
Okay, F1 is 0. Is there anyone who can do, Shana, can you do F -1? And Ayabukwa, can you do F2? I'll wait for those. Probably talk more about actually what's going on here, maybe.
So for -1, I got -8.
-8.
Mm-hmm.
Someone quickly do number, I know I gave it to Ayabukwa, but if you can quickly do it, please. Anyone who gets it first.
F2 is 1.
Is 1. Okay, cool. Let me just take a moment and just go back and probably talk about what's going on here. Remember, when you were solving for the y-intercept, you would let x is equal to 0, right? Are we happy?
Yes, sir.
So when you are solving
Yes,
for
sir.
the x-intercept, you let y 0. You let y to be equal to 0. So if this was a function like this, what you are doing by letting y equal to 0, you are looking at these points. You are looking at the x-intercepts where this is 0. So these are the x-intercepts. So if you guess an x value and you get the function being equal to 0, that's your x-intercept. Y is 0 for an x-intercept, right? So that's why you would normally just choose the one that has 0. So you will choose the one that has 0. If you look at that guy over there, it has 0. So you will go with that one. So, no. So you would go with that one. So now x is equal to x is equal to 1. So it means that x minus 1 is a factor of that expression. What does that mean? Basically means that if you were to take x minus 1, multiply it with something that could be left behind, which would have to look like this, ax squared plus bx plus c, you should get that business over there. So you should get x cubed minus 3x squared plus 3x plus 1, minus 1 rather. Right, do we see that? So now our task is to find this one, is to find that. If we find that, we are very close. If we want to factorize that, we can factorize it further, and our life is simple. But this is an equation on its own, right? So if you think about how you could find that, if you would have ax squared plus bx plus c, and you divide by the x minus 1, you would be left with, you would have what I'm writing now. Like that. I'm gonna pause there. I want people to engage with me. Are we happy? Is everyone happy?
Why are we dividing by x minus 1?
Because remember, this x minus 1 was right in front of this guy, and we want to get rid of it so that we can find the ax squared plus bx plus c. Happy?
Yes, sir.
Ew.
Yes, sir.
Okay. So now we have to do that division. Now people choose to do this division the way that they want. Actually, I don't know any of the other ways that one can do this division. And actually, this is the beautiful way of solving this problem. I recommend it because of more reasons, guys. Number one, you just have to know how to divide these things. If you don't do it this way, you might know how to solve this problem, but because you don't know how to divide these, you might struggle in certain questions where people are asking you to find remainders of, of certain things. I'll show you. I'll put it in there. I'll put a question like that in the TAT test. So what is being divided goes under this thing that looks like a radical, looks like a square root, goes under that. That's this thing that's being divided. And what you are dividing by comes here. And the guy that you will always have a conversation mostly with is this guy over here. right? So the first conversation is, if you take this guy and you divide it by x, what do you get?
X squared, sir.
Yes, you get x squared. So you get x squared. Maybe let me choose a different color for that guy there. You get x squared. If you take that x squared, you times it by that green guy, the x, what do you get?
X.
X cubed.
X cubed.
Yes. I'm looking for a different color for this.
Use the rainbow, please, sir.
Rainbow, okay, cool. Okay, so you would have x cubed like that. Are you happy? Okay, so now, after getting that x cubed, oh, sorry, you said you must say x times that x, you're gonna get x cubed, but you must again say x squared times negative x. What do you get?
Negative x cubed.
Yes. Are we happy? Negative x squared, sorry. Are you following? That's going to be negative x squared. Is everyone following this? I want to have a conversation around this.
No, I'm not.
So basically what you're doing is that it's like you're distributing this, you're multiplying it here, and then you multiply it here. You multiply it there and you multiply it here. Are we following, guys? Siyavana Bahlali?
Yes, yes, sir.
So we times the x squared with the -1.
Yes.
Oh, okay, okay.
Are we happy?
Yes, sir.
Okay. And then at that point, we can, I'm struggling to adapt to the rainbow. I think I would use the rainbow for a less complicated, like for something that doesn't, because I'm trying, yeah, it's difficult for me to follow the rainbow. Okay, I'll just change the color of that rainbow to that. Okay, anyway, and then you divide, not divide, sorry, this is not a division line. So you will sort of like multiply the negative, this negative that's outside, you're gonna multiply it right through there. So what's gonna happen is that you're gonna have a negative x cubed and a plus x squared. And the x cubes, when you sum them, because you're gonna have a negative x cubed plus that x cubed, you're gonna get a 0. On the other side, here you're gonna get a negative 2x squared because you have a negative and you're adding an x squared. That's positive. So you're just gonna have that. For everything else that you didn't touch in that process, is gonna be left like that. So this is gonna be 3x minus 1. Then you start the process again. You come to your green guy, you're like, dude, if I take this and divide it by u, what would I get? Right, so you say minus x squared divided by x. What is that?
It's negative x, sir.
It's, look at it again, negative 2x squared divided by x. What do you get?
Negative
With
2x.
negative 2x cubed.
No, divide.
Because you divide.
So it's
in
minus, so
right?
it's negative 2x, okay.
Okay, Songesel,
Yeah.
are we all following? So after you have your negative 2x over there, then take that negative 2x Can you guys hear me?
No, sir, you're breaking up.
Okay, can you guys now still, can you hear me properly now, or is it still the same?
Yes,
We
sir.
can hear you, sir.
I can hear you, sir.
Molweni.
Okay, can you guys hear me?
Yes,
Who
sir.
you know
Yes,
who?
sir.
What?
Okay,
You know who?
guys, please don't, can you, we have, okay, so you now have this negative x, you times this negative 2x rather, negative 2x with that x, and you times it with the -1 as well. So you're basically timesing it with that bracket. And this is what's going to come out. You're going to have negative 2x squared and positive 2x. And you put bracket on top of that, you minus that. So once you've minused it, you will see that this negative is going to get inside. So it's going to be positive 2x squared. And then this is going to be negative 2x. Now, once you have that, you know, this is positive 2x squared, this is negative x squared. So this is going to give you 0. Whereas this one, it's negative 2x, you know, so it's 3x minus 2x. So that one is going to give you x. And then you can bring this negative 1 down as well. So when you bring that negative 1 there, it's that, right? And you start the process again. You say, you know, x divided by x, and then you get a positive 1. You take that positive 1, you multiply it by that whole entire bracket, and what you get, and what you get is x minus 1. You put brackets, you subtract. You will realize at this point, these things are the same, you get 0. So now, this guy that we were looking for, we see totes, we get it, we got it. He totes, that's the Sotho. Yeah, but we got it. There is there, you know. So we kind of know now. My apologies, this laptop can actually just switch off. I know it. It's very rude. Doesn't notice me. So now remember we had that x minus 1 of ours. We know now if we were to multiply that x1, that x minus 1 with minus 2x plus 1, we would get x to the power 3 minus 3x squared plus 3x minus 1, right? So we would get, you know, probably the way that you would probably like to write this is the other way around. It's to say, if you have this, then probably this sort of like factorizes to that. Maybe you'd be more happy to write it that way. Okay, and then you can simplify this a bit further. You know, that bracket, you can factorize it anyhow you want. You know, this could be x, this could be x, this is 1 and 1, negative and negative. So that's our, you know, we factorized it. If they cared about, you know, they said they wanted the solution. So this would be x is equal to 1, or x is equal to 1, or x is equal to 1. You see, I'm writing all my x's. I don't want people to write x's once. But anyway, let's see. Did everyone follow that?
Sir, can you please
Go through that
plus
again.
1?
Okay.
Please go through it again because
Okay, it's fine. I'll go through it again. Like, let me start from, let me just make another example. I'll make another example. We have x to the power 3 minus 5x squared plus 8x minus 4 is equal to 0. We need to guess a solution, right? Or a value of x. Guess a solution. It's not really a guess. Maybe it's a guess. Yes. So we're going to try x is equal to 1, try x is equal to -1, try x is equal to 2, and look at which one works. Can someone tells me which one works or which one where you get 0?
1, sir.
1, you get 0. So it means that x is equal to 1 is giving us 0. So it means that x minus 1 is a factor. So if x minus 1 is a factor, this basically means that if we're to multiply x minus 1, or maybe let me write it differently this time around. Let me say if x cubed minus 5x squared plus 8x minus 4 was to be factorized, we were going to be sure that we're going to have the x minus 1, and we're going to have this version, ax squared plus bx plus c. We were going to be sure of that. But the problem is that we have this thing that we want in a general form. We actually need to know what that is to successfully factorize that, you know, to have said that we have factorized it. So we need to know what that is. So to get that, we can divide both sides by x minus 1, which is this guy over here. We can get rid of that by dividing both sides. So we're going to have x cubed minus 5x squared plus 8x minus 4. And then if we take that and we divide it by x minus 1, we're then going to have the ax squared plus bx plus c. We then say, okay, let's think about ways that we can divide this. And someone screams and says long division. So of course, we're going to do long division. And when you do long division, you say x minus 1, you put what you're dividing by outside this thing that looks like a radical, or square root rather, like yes. And then whatever that you are dividing is put inside the square root. And then this is your question. You look at this guy, you say, if I were to take the first term that's there, divided by, you know, that x, what would I get? You know, what you're getting there is going to be x squared. You know, you're going to get x squared. And you say, if I would take this x squared, multiply the whole entire bracket and with x minus 1, what would I get? If you do that, you will get x cubed minus x squared, and then you must put brackets that and subtract it from that original expression. So you subtract it. So if you know, if you think about what that means, it means that then the x cubed that the x cubed would now be negative, and then the minus x squared would now be positive, right? So you just draw a line for you there for yourself. What you're going to have here is that you're going to have 0 when it comes to the x cubes. They're going to cancel each other. And then on the other side, you would have, you know, a minus 4x squared, you know, because this, you have minus 5x squared there. And then this is minus, going to combine with this is going to be positive. Then when you add those, you're just going to get a negative like that. Then you can bring down your 8, you can bring down these and bring down that, you can bring down those. And then you will be left with a plus 8x minus 4. And then your question can start again, like, dude, if I could, you know, sort of like divide this minus 4x squared by u, what would I get? And you know, if you say minus 4x squared divided by x, you're gonna get minus 4x. Then you say minus 4x times the whole entire bracket there. You know, if you times, you know, if you do that, you're gonna get a negative 4x squared and a plus 4x. You put brackets, you subtract. And once you've done that, you put your line there if you want. And once you've done that, that's going to be positive, you know, so you're going to have positive 4x squared and a negative 4x. So what you're going to end up having here, it's a 0, but on the other side, you will just have a positive 4x, because you would have said 8x minus 4x. Okay, you didn't touch that, guys, so you put it back. You have your minus 4 there. Start again. Like, dude, if you know, you look at this guy like, okay, if I were to take this 4x and divide by u, what would I get? You know, and then you say, okay, that I would get a 4, right? It consistent with color, right? Get a 4. If I would take that 4 multiplied by the whole entire bracket, it would just be 4x minus 4. And you can put your brackets and subtract it. They are the same. You will get a 0. You are done. So now at this point, you know that long division of your, you know that you had x to the power 3 minus 5x squared plus 8x minus 4. You knew, you guessed the first solution, but now you're getting the other solution, you know, which is just x squared minus 4x plus 4. Now that's a quadratic, and we are happy, or we are okay with factorizing quadratics. So you kind of know that this is going to be x, you know, this is going to be 2 and 2. They're going to both be negative, and you are done. Did anyone not follow that?
I did not follow it.
Okay, where did I lose you?
I was not here when Sir started, so I kind of feel lost, even when Sir explained everything over again.
Oh, okay.
Yeah.
Okay, then it's going to be difficult because you were late for class. So you're probably going to have to watch the record of this class from the beginning.
Can I please ask?
But Sir, you can explain again.
Wait.
Maybe I'll get it.
Wait, I was addressing, when I'm addressing the question, can I please finish and make sure that the person that I was talking to is happy, then I can move on. So I think that was Lisa, right? Lisa, you were saying you're not following what's going on, right?
Yes, Sir. I think I picked up something in this explanation. So can you like explain one more time? And I promise I'll get it, because it looks simple and easy if you get it, but then it looks kind of tricky at the same time.
Okay, I will make a last example in our next session. So this class will end, then I will start another. You know how Zoom makes you, you know Zoom things, right? Anyway, can I take another question?
Yes, Sir.
I'm taking another
Yes,
question.
sir.
Is there any other question? Okay, there's no other question. Okay, maybe in this time, since there's no other question, maybe I can take these last 2 minutes to just go over what's going on here. So this question starts here, right? So the first thing that you could sort of like have to do, you need to guess a solution. Let me just choose a different color for these ideas. Ooh, I can't change that one. Ah, which color am I changing? Okay. I don't know. Okay, I'll change this one, take pink. Okay, anyway, number one, you should guess a solution. Are we happy with that idea of guessing a solution? Just raise your hand if you are happy. Okay, cool. Guess a solution. After getting a solution, you have to make a solution a factor by just taking the one to the other side such that it's a factor like that. Number three, you need to understand what that factor means. It means that, you know, that's one of the solutions that you have. However, you need to multiply them with another thing that's a quadratic to get your thing. It's the third thing. The fourth one, probably this is also an important part. However, the sixth one is to realize that to get that number 5 part, you need to divide both sides by x minus 1, such that you are able to find your number 7. And then the long division part is just computing number 6. You are computing this. You are trying to calculate this. What is this? Which is the right hand side? You know, and then you just put it through a long division and you start doing the long division. But if it's the long division that you do not understand, I'll make one more example, right, in the next class. So I'll exit this class and I will start a new one just now. It would have a new link.